is the lesson for Chapter 8, Section 1, titled Adding and Subtracting Polynomials. And so let's take a look at that term, polynomial. But before we take a look at polynomial, let's take a look at what a monomial is. And so here's a monomial. It's just a one-term polynomial. And so one term, it could be a constant like 18. It could be a variable like z. It could be a combination, a product of a constant and a variable. It could even be a series of variables, or it could be division as long as we don't divide by the unknown. So notice how all of these x's or z's, any of the variables are on top of the fraction, especially this one here. So when we are adding or subtracting monomials together, those are called polynomials. Now, the degree of the polynomial is the exponent on the variable. So for instance, here we have 5x. So this is a first degree because the exponent on the x is 1. Where this one, if we have more than one variable, we add up how many exponents we all have, and that makes 5. And so this is a 5th degree monomial. And on this one, there's actually a 0 degree because we don't even have or see an x. That means x is to the 0 power, which makes 1. And so that's what we end up seeing. Now, there's a standard form for polynomials, and that's when we have the highest exponent term and then the next lowest. So this is called descending order. So where we go from the highest exponent down to the lowest exponent. See how the degree of the monomial goes from a 4 to a 2 to a 1 to a 0. And so that's the standard form that we're going to be putting things into. So I'm going to be using that vocabulary as we take a look at these problems. One more thing, I guess, a degree of the polynomial, it's important. This is a 4th degree. It goes always by the highest degree term. And so let's take a look at some of the problems that we'll end up seeing on the homework tonight. And we'll see a lot of simplifying, adding and subtracting these polynomials from each other. And so let's take a look at our first one. We collect like terms. So you see how 8z plus 6z, that's going to end up giving us 14z. Don't change the exponent because we're counting up how many z's we have. When they're opposite signs, we subtract. So that's going to give us minus 3, and that would be our answer. Over here, again, we're still adding, so we go ahead and collect like terms since they have the same variable raised to the same power. So that makes 13x to the 3rd power. Again, do not change the exponent because we are counting up how many x to the 3rds we have. Here we have 3 plus 7 makes 10, and so that would be our answer. So over here we have some j squareds that we can combine. So 6j squared, 3j squared makes 9j squared. Over here they're opposite signs, so we end up subtracting, but there's more positives than negatives, so that's why it's a positive 2j. Over here we get minus 1 because we have more negatives than positives. And that's our answer. Oops, I need a 9j squared there. Again, do not change the exponents when we are adding or subtracting these terms. So the difference here is that it's in a different form. See, this polynomial has parentheses around it to show how it's one term, and there's another polynomial. But we can collect like terms because we can use the commutative property. So these two terms will combine together. Oops, actually they will not because this is a k and this is an x. So let's go ahead and fix that. So we cannot combine these two terms. And so when I go ahead and simplify it, I'm just going to go with the 3k squared first. So I'll write 3k squared, and then I'll write the plus 16x squared. And so typically when we write in standard form, we write the highest exponent first. Well, these are the same. They're the same degree terms. So I'm going to start with the letter that comes first in the alphabet. Now I can combine the 5 and the 7 because they are both to the first power. They are ones that are both constants, and so that would be my answer. So over here, I start with the highest degree term. See, there's no other g to the 4th to collect with, so I'll rewrite that. Then I have a negative g to the 3rd power, nothing to collect with, and then nothing to collect the negative 4g squared either. And so then I have just the positive 8g and the 11. So nothing to combine. I didn't combine any terms. I just rewrote it in descending order. And so over here we have some subtraction. So whenever you have subtraction, that minus sign, always go ahead and distribute that. Distribute that or just add the opposite, and the signs inside the parentheses will switch. So it's a negative 5n and a positive 11n gives me 6n. Negative 4 minus 2 gives me negative 6. Again, same sign, you add, opposite sign, subtract. So again, when you see that minus sign in front of the parentheses, switch all the signs. And so this becomes a plus negative, and this is also a negative. So all the signs switch. It's like distributing a negative 1 over those terms. So I can subtract these two. They're opposite in sign. That makes a negative 1x squared. And I'm going to go ahead and fix that real quick. So negative 1x squared. And then over here they're opposite signs, so I subtract, but when we're positives than negatives, so that would be my answer. Now, you could write it just as negative x squared plus 7, and that would be fine as well. So on this one, we'll add the opposite, so all of these signs will switch inside the parentheses. Just inside because that's what the negative was in front of. This term didn't have a negative in front of them, so nothing changes here. So it becomes just a 1d squared plus 15d and a minus 8. They're opposite signs. We'll subtract, same sign we add, and that's what we end up coming up with. So over here we have just more terms to collect, and so we have 28e to the third, 19e to the third. These two collect together, and again, you keep the variable term the same, just add up the coefficients. So that makes a 17, carry a 1, so that makes 47. E to the third power, and then plus 3e squared and 2e, or just 1e squared makes 4e squared. So the 3e squared and the e squared, 1e squared make 4e squared, and that would be our answer. So over here we have that minus sign in front of the parentheses, so that's going to switch all the signs inside the parentheses. So I just either add the opposite or distribute the negative over those terms. So then you look to see what you can collect. I got an h to the fourth. So negative 12h to the fourth, positive 6h to the fourth makes negative 6h to the fourth power. Then I look for the next term. Next highest degree term is this one. So I'll write minus 3h squared. And then I have an h and a positive 4h. And so that's going to end up giving me a positive 5h, and that would be our answer. So moving on to the next type of problem that we'll end up seeing. Here we have a quadrilateral shaped pasture that says has a length of 3a squared plus 15a plus 9. So this is like the perimeter. The perimeter is equal to 3a squared plus 15a plus 9. Okay, so then it says the three sides of the fence are given to us. And so basically we want to find out what the missing side is. So what I'm going to do is I'm going to subtract all of these from that perimeter. And so when you subtract, all those signs are going to switch. So I take away 5a, so it's going to be a minus 5a. And then here I'll add the opposite, so all of these signs are switching. So it becomes a negative 10a plus 2. Again, all the signs switch inside the parentheses there. So it's a negative a squared plus 7. So now I can go ahead and collect. And so I'll collect the a squareds, so a 3a squared. And I go way over here to the minus a squared, and that makes 2a squared. So I'm going to cross these off since there's so many terms here. And then I have a 15a minus a 5a minus a 10a. Well, those are all going to cancel because the minus 5a minus 10 make 15 plus, and then that's a negative 15a plus 15a makes just 0. So those all cancel out. And then I just have this 9 and 2 make 11 plus 7 gives me 18. So there it is. That is the missing side. Missing side length, and they don't give units, but I'll just write down units. So that's what we end up doing for that problem. Let's take a look at the last few problems, just kind of similar to what we saw before. Again, anytime you see that minus sign, add the opposite, switch those signs. So it's a 3a squared, and then I can combine these two, makes a negative 1a plus 10. Again, they're opposite signs, so that's why I subtracted and got the negative 1, more negatives than positives. Looking at the next one, I look for the highest degree term. So it's this one right here, the negative 10d to the third, and then I'll add the opposite on all these to switch all those signs, and I'll collect the negative 5d to the third. So that makes a negative 15d to the third power. And then I look for the next one, it's this one here, positive 3d to the second power. And then I have a negative 3d and a positive 6d makes a positive 3d and then a plus 4. And that is the answer. So look at the last one, or second to last one here. We are adding this time, so no need to change signs when you're adding. Only when you subtract do I change signs. So this is a negative 4s to the third. Can't combine anything with that. And then I rewrite the negative 2s to the second. Nothing to combine, but these two you can. A 2s and a 1s make a 3s. And then the negative 3 and the positive 7 make a positive 4. So that is our answer. So look at the last one here, looking for the highest degree term. It's this right here, 8p to the third power. And then the 2p squared and the 9p squared make positive 11p squared. So again, I'm adding, so no need to change any signs. Negative 6p, negative 5p, the same sign, so I add the two numbers, negative 11p. And then we just bring down that negative 11. Nothing to combine it with because there's no other constant. So those are the types of problems you're going to see on tonight's homework. Good luck.